Hello guys, I hope you are doing well. In the previous session, I have taught you that several methodology for the life cycle assessment that, for example, we investigate together for example, the global and the European, and now we go to the special methodology to the life cycle assessment in the SimaPro software. I turn on the laser pointer and go to the another approach about the cumulative energy demand CED. The cumulative energy demand method is used to calculate the total energy used, the total energy required over the life cycle of a product system. It is based on the ecoinvent methodology and uses higher heating values, which represent the total energy content of the fuels. The result is expressed in the megajoule, making it easy to understand and compare. Unlike other life cycle impact assessment LCA method, CED focuses only on energy use and not on environmental impact like emission or toxicity. Let's have a look of in the CED about the energy categories in the CED. The CED divides energy use in the different categories. This includes non-renewable energy sources like fossil fuel or nuclear, and also the renewable energy resources such as biomass, solar, and wind. This method calculates primary energy demand, meaning the total energy extracted from the nature before conversion. This helps us understand how much energy is truly required by systems. But this method has some features and limitations. CED is a simple and practical method. It does not include normalization, and all categories are given equal importance. This methodology makes is easy to use and understand. However, it is only measures energy demand, as does not consider environmental impacts such as emission or pollution. Also, wood often is excluded because it is commonly used as a material, not just as the energy sources. About the cumulative energy demand CET LHV method, this slide summarizes the cumulative energy demand method based on the LHV that's developed by a PRA consultant using the ecoinvent database. And for example, we can use this methodology in the SimaPro software for the energy analysis. And also, this methodology calculates the total energy demand based on the lower heating value, LHV, because as you know, for example, we have a methodology for the CET. One, for example, based on the higher heating value with the abbreviation of the HHV, and the other based on the lower heating value, LHV. And also the LHV excludes heat of water vapor, for example, but the HHV includes total heat higher than the LHV. For example, if I want, for example, give you the better explanation about the difference between the LHV and HHV, the HHV also considers for example, vapor difference enthalpy for vaporization for the fuels, and this is the difference between the LHV and HHV. And also, for example, original CED that I previously explained to you uses HHV, but for example, in this methodology, converted to the LHV using ratio. For example, if I want to give you that, for example, one example, the only difference between the CED based on the HHV and LHV based on the, for example, the energy consumption method between the HHV and the LHV. And also you can say the conversion ratios from the ecoinvent guideline table 5.1, and ratios are also depends on the fuel type. For example, in the special case peat, no data are available. As assume the ratio is equal to 0.85, slightly lower than the lignite, provides more realistic usable energy values. That, for example, in the comparison, because for example, in the some cases and sometimes, for example, we don't have any information about the enthalpy, the vaporization enthalpy. So, for example. The LHV method gives us a more precise data in comparison with HHV, but also it is important to notify that for example the HHV method is very custom in comparison with LHV. Another important thing about the cumulative exergy demand CExD, that, for example, as you know, that we have a difference between the energy and exergy, that for energy encounters with the quantity of energy, but exergy encounters with the quality of energy. This is the difference between that energy and exergy. This methodology is based on the ecoinvent extended database and measures the exergy megajoule, and that's a useful work potential. That, for example, if I want to you, for example, for several years, I have those the exergy courses, and also if, for example, if I want to teach you the difference between the energy and exergy, imagine you have a one bottle of the hot water, for example. This bottle of the hot water, you put it on the table, for example. It is quite clear that this hot water has the energy, because, for example, the hot water that you use energy to heating it up. But in general, it does not have any, for example, exergy, because you don't gain any useful work and energy from this. So, for example, as I explained to you, Exergy encounters with the quality of energy and energy with the quantity of energy. For example, natural gas, for example, if you burn the natural gas, because the heat have a higher heat source temperature, has a higher exergy. In contrast, for example, lower temperature heat, such as low geothermal thermal energy, has a lower exergy because it has, for example, lower temperature. And also, as you know, the exergy evaluated loss of useful energy resources. And for example, and also, if I give you the additional data and information about the exergy analysis, you can, for example, you imagine that, for example, by the exergy analysis and for example, I am a little bit mixed up about the useful about the using of the exergy analysis. You can do the exergy analysis for every systems, and also you can calculate the exergy efficiency based on the quality of the exergy, and also you can also, for every component and or every subsystem, you can calculate the, for example, exergy destruction rate with the abbreviation of the EDR. By this methodology, you can easily distinguish the, for example, that's which of the component has the highest Exergy destruction rate and EDR. So we can solely focus on it for optimization or better performance in order to for example improvement the efficiency of the total system. Anyway, in this system about it, and so I think that explanation, because the main target of this teaching about the life cycle assessment with the SimaPro software, and also, for example, so I think the explanation about the Exergy is enough. In this case, you have no normalization and weighting is equal to unit, and updated categories, for example, for the fossil nuclear metals, water unit megajoule, and includes new energy and water fuels. And also about the characteristics factor for the gas is 0.95, for the oil 1.02, and for the biomass 1.05. That, for example, I think the explanation of this slide is enough. So we go to the another approach about the ecosystem damage potential, or EDP. This slide presents the ecosystem damage potential EPD method based on the ecoinvent 2 database and developed by the ETH in the Zurich in the Switzerland. It evaluates environmental impact related to the land use, including land occupation and transformation, which affect ecosystem biodiversity and natural function. No normalization is applied, and all impact categories have equal weighting factor, which is equal to unit, same unit for the all categories. Overall, the method helps assess how land use changes the impact ecosystem and supports sustainability and LCA studies. About the another methodology in the SimaPro software about the LCA life cycle impact assessment, greenhouse gas protocol GH protocol. This slide explains the greenhouse gas protocol GH protocol developed by the WRI and CExD for the carbon footprint analysis. It is based on the IPCC GWP for the more than it is based on the IPCC GWP for the 100 years, and includes carbon uptake and also distinguishing between different carbon types, fossil, biogenetic, land transformation, and stored CO2 that you can see here. Fossil and biogenic carbon must be reported separately, while land use change and carbon uptake reporting are optional. Results depend on the databases, and accurate separation is best supported by the ecoinvent database. This method uses IPCC 2013 factor, and results are expressed in the kilogram CO2 equivalent. So this is the short explanation about the GHG protocol. Another methodology about the IPCC 2013 GWP 108. This slide represents the IPCC 2013 global warming potential in the 100 years method, widely used for climate change assessment. Is calculate global warming impact based on the direct greenhouse gas emission, like result expressions in the kilogram CO2 equivalent. However, it does not include indirect effects such as CO2 or NOx or some atmospheric interaction. There is no normalization or rating, making the method simple and transparent. Updated factor methane correction improve accuracy. Overall, it is a reliable standard method, but mainly focuses on the direct climate effects. Another methodology about the IPC 2013 GWP for the from the 20A. This slide represents the IPCC 2013 GWP for the 20-year method, which focuses on the short-term climate impact. This IPCC 2013 GWP on the, for example, excuse me, for the long-term impact, but it is for the short-term impact. Compared to the 100-year method, gases like methane have a much higher impact in the shorter time frame. This methodology considers only direct greenhouse gas emission, which result in the kilogram CO2 equivalent. It does not include indirect effect or atmospheric interaction and has no normalization or weighting. Updated methane factor reflects its strong short-term warming effect. Overall, this method is useful for analyzing near-term climate change and mitigation strategy. So I think for example, in the another session, I think I completed and finished all of the method used in the SimaPro software. Have a nice day and goodbye.